Alright, hello everyone. What we're going to do is we're going to start off with matrix operations and definitions. Now this chapter is going to contain a lot of what we've already covered in the IGCSE course. So we're going to go through this chapter very quickly. But let's just go ahead and make sure that we refresh our minds with what we've already covered. And let's just go ahead and start off with some of the basic definitions and operations that we have and that we can use with matrices. So notice that we have matrix A, B, and C. Notice that the matrix is denoted by a bold capital letter. In addition to that, you can either use brackets or you can use parentheses to go ahead and contain the numbers which make up the matrix. And notice that what we have is we have the dimension or the order, and remember this is the number of rows by the number of columns that you have. So there's only 2 rows, 1 column, 2 rows, 2 columns, and 2 rows and 2 columns there. So what we can do then, being that we know that this one only has 1 column, we can call this a column matrix. Both of these here will be a square matrix because of course the dimension for the rows and columns are the same. Now we can also go ahead and talk about the actual values that are within the matrix itself. So we can call all of those things elements. So if I was to go ahead and talk about the element in matrix A sub 1, 1, then we're talking about the value of 1 because that's the element that is in the first column element. If we were to go ahead and take a look at the matrix B, notice the element 2, 1, which corresponds to the second row, first column, B element is actually going to be 3. And notice that in here, for the C matrix, we can call -1 the second row, second column element. Okay? Now, we've already talked about a lot of the operations that you can perform on matrices, and one of them is addition and subtraction. And notice that what we said, in order to add matrices, you have to have the same dimension. And the reason for that is because you are actually going to be adding corresponding elements within the matrix itself. So if we go ahead and take a look at A plus B, notice that the dimension for A and notice the dimension for B are different, and therefore you cannot add or subtract them. But if we were to go ahead and take a look at the 2 square matrices here, which are 2 by 2 and 2 by 2, then we can go ahead and talk about B plus C as just being the sum of all the corresponding elements in the 2 matrices. So you come out with 3, 6, 3, 3, and notice that one of the things that I can do is I can actually factor out the 3 from each one of the elements that we have in the matrix here, the resulting matrix here, and we can write this as 3 times the matrix 1, 2, 1, 1. And notice that this is just an example of scalar multiplication. Okay, lastly, we have matrix multiplication. And remember that what we said with matrix multiplication is that whenever you multiply the 2 matrices together, the dimensions that are, say for example, for A, M by P, and B would have to be P by N, the key is to make sure that these 2 dimensional values are actually equal. And what happens then is that if we do have these, we can go ahead and multiply the 2 matrices together, and we can come out with a resultant matrix that is going to have exactly the same number of rows as A, and exactly the same number of columns as B. So the resulting matrix is going to have a dimension of M times by N. So if we go ahead and take a look, say for example, at the matrix multiplication BC, which is right here, notice that what we're going to come out with is being that this dimension here and this dimension here are both the same, then the resulting dimension is still going to be a 2 by 2 matrix. Now remember what we said also is that if we go ahead and multiply 2 matrices, we take the first row, multiply it by the first column, we take 1 times it by 2 and 2 times it by 0, add those 2 together and you come up with a value of 2. That's going to be your first row, first column element. You do the same thing for the others and you can come up with basically what BC is, which would be 2, 2, 6, 8. And again, we can use scalar multiplication properties to go ahead and factor out the 2. Okay, so there you go. One other thing, just to recall, remember that A times B is not always going to be the same thing as B times A, and so therefore we're going to say that those 2 are not going to be equal. And in other words, we can say that matrix multiplication is not commutative. Okay, so I think that should be a very quick refresher for all of us with regards to matrices, the simple operations that we have, as well as some of the important definitions regarding the matrix itself. So give it a shot, we'll see how everybody does, and good luck. Okay, see you later.